Hello, everyone. Welcome back to another episode, and this is the fifth part of our optimization series. Previously, we have explained the genetic algorithm, particle swarm optimization, artificial bee colony, improved gray wolf optimizer, and now it's dragonfly algorithm. So, in this video tutorial, I will talk about how the da.m script file works, how you can optimize your objective function, and how actually does it works. So this code is actually get from the Sayyid Ali Miraj Ali website, and I will put the link in the description so you can easily download that code. So you can utilize this code into your project, and this video is for educational purpose, just to brief you how does it works. So without any further ado, let's get started. So after extracting the file, here is the main file. This is the main file. So previously the improved gray wolf optimizer, you can see at the I button in the top right section, and it's exactly the same objective function or the cases which we are considering right here, because both codes are designed by Sayyid Ali Miraj Ali. And in this video, so in start of program, let me left click here to start the program, and let me click on the change folder. So now we are into this folder, and after clearing all the variables if they are in the workspace, and then clearing command windows, and now we have the program have initialized the search agents, how many search agents we want to proceed. So here is the function name. Function name is called is f1. Here in this code, there is a file which is get function details. So in get function details, there are different cases. So just like if we have an objective function, and an objective function have different sections or different categories inside. In case of load flow analysis, for example, if we want to do real power injection or reactive power injection, or we want to consider both, or we want to choose without any kind of injection from the external source. So that's how different cases works, and in this case we are just considering this f1 because here f1 is selected. So if you want to proceed with any different case or different function, you may change that to from f2 3 4, or any number between the f1 and f23. And then there is a section of maximum iteration section, and then there is and here is a call for this function get function details. This is the name of the function, so the name of the functions should be exactly same to the file name. So in file name, this is the file name and it's exactly same. Let me open the file, and here you can see that there is get function detail, so it should be same. It should be same. It should be same here, and in the as the name of this file, and the line where we are calling the function. So this is the function name. The right side of this function call, this is f1, and here we are going to send our input to this file which is f1, and this will be the output which we get from this file. So let me left click here again, and let me click on step, and now we are into the f1, and based on the f1 we have lower bound, upper bound, and the dimension, or you can say the vector. Okay, and at the at line number here, this is the get function details, and here our function details is going to be end, and now we are out of this loop. Let me click on step. As we have choose f1, so these are the lower bound, upper bound, dimension, and the objective function which we name it as the f1. Here you can also see that this is the fobg, so all the variables are will be stored in the workspace. And after that, now we are going to send this data, these four variables, and there is a addition of search agents, maximum iterations, and these four. So we are now sending these six variables into the da.m file. So it's da.m file, and now we have to get into this da.m file. Let me click on step. Okay, and now this is the six numbers which we send from our main file into this da. And after by using these numbers or this data, we have to find these outputs: best score, best position, and the convergence curve. So best score will be the fitness value, and the best position will be the numbers or the input data which we have to put into our objective function, and this will be the fitness value for that numbers. And here there is a display here. So I just restart the program again, and in the start of the program, before execution these lines, I just put this command here, this section, and this is giving me the answer of 1. So here 1 is exactly same to the 1. If I remove 1 equal from here, so this condition will not be true. So if you want to put a condition, if else, and you just make sure to place double equals sign here. So 1 equals to 1, so this condition will be true. And now let's out of this loop here. And there is some food fitness and enemy fitness evaluation here. So how does this work is actually here at this point. The important part is the food fitness and the enemy fitness. Both these fitness functions represent the fitness values for the best food sources, and the worst food sources, which is named as the enemy. So both the food position and the enemy position represent the positions solutions associated with the food and enemy respectively. The fitness will be their fitness when we have to put that into our objective function. So as we have initialized them with the infinite, and when our fitness function or objective function converges for the first time, we will replace that infinite with that number. So next there is initialization. Initialization means we are calling this part. This is the initialization part, and here we are putting the number this data into the initialization part. Let's get into the initialization part. Let me remove that. Let me click on continue, click on step. Okay, so in initialization part, we want this function initialize the first population of the search agents. So we want to initialize the positions. Here is some boundaries numbers, variable initialization. If the boundaries of all the variables are equal, and use enter a single. And here there is a verification for the boundary. So this is actually the case when the user enter the same upper bound and lower bounds for some cases, but this time it will not be correct. This will we will go with that. And here we are finding the upper bounds, new upper bounds, and new lower bounds. And here is some each variable has different lb and ub. So here we have to calculate the positions, we have to update the position. So based on the random selection and the search agents, we have just defined over the positions. Okay, let me show you the positions here. Here you can see that we have 40 numbers here, and each time let me click on continue again. Okay, and now we have updated our positions. So each time let me click on step, let me click on continue here, and right now in the positions we have, so here we have let me show you that inside the DA, inside, sorry, main, we have 40 search agents. And we have the 10 numbers which we want to evaluate here, right? Let me open the positions. So these are the 40 numbers. So these are the search agents, and this is the first one, this is the second one, this is the third one, this is the fourth one. So we are actually finding the best from all these 10. Next, let me click on step, and here we have delta x. That position is actually, which is 10 rows and 40 columns. So that is actually stored into the delta x, which is our the initial part of the positions of these. And then there is a iterations part starts, which is ended on the 210 line number. Let me click on step, and here finding the r and w, these factors we have to, you can see that these are used in our program for multiple times to evaluate the food sources and the fitness function. Here is some more calculations related to that. So right over here, this part, which is actually the S, that is actually the separation weight. A is actually the alignment weight. C is the cohesion weight, and the F is food attraction weight, and E represent the enemy distraction weight. And MYC here is actually defining the upper bound for these sections weights. And it's a parameter that defines the upper range for that, and it's just like a working like a magnitude here. So all these weights given to the uh, assigned a behavior to that which we have to evaluate further. And here in the search agents we have the objective values first. Here there is a call for the function fobj f1. So right here, let me run the program again. Okay, right here, let me click on step into the fobj. Here there is a function of fobj, and we are into this file f1. Here there is a fitness. This is the actually the objective function. Previously these are the numbers which we assign for each function, and here is some calculation for the objective function or the evaluation of the fitness. So after running this, we get the fitness value for our function, or we find the fitness value for the numbers which we have put in form. So we store our data in the variable x, and then we put that data into fobj into get function details.m file, and after that we find the fitness. And here we have to compare the fitness our food fitness is infinite, and definitely this is less than the infinite, so we will update our food fitness. And in food position we have saved that number. This is the first number we have saved that, and initially it's 0, and after that it will update its number. So we just update our first column, we save first 10 numbers. Similarly we have the 39 other numbers. As you can see here in X, we have 10 rows and 40 columns. So here we have stored our first column, and there are 39 columns left. So this is the this loop will run for the 40 times. Let me get out of this loop, click on continue. And here in the food position we have that numbers. And this is the case, if we get the better fitness, then we will update the numbers. So in these now we have the updated numbers. Now there is some calculation for the enemy fitness, and in enemy fitness, let me click on step. If our fitness and enemy fitness is minus infinite, and this is the fitness which actually converts, and this will be the true. And this is the AND case, means both these this part should be true and this part should also be true. So if both parts are true, then we will be get into this loop. So all, and all is actually the built-in MATLAB command. Just I write doc all, and it will show that how all is works. So there is a call, and let's see, yeah, it's converts. And our fitness which is right here, we just put that fitness into our enemy fitness and we update the position. So right here this loop will be ended, and this loop will be running for 40 times. Let me click on continue. Okay, so right here we have the enemy fitness, which is worst number, and this is the food fitness which is the best here, 1.3536, and this is the 6 point. So we stored the minimum and maximum possible numbers, and here there is another call for the search agents. We want to run this loop for another 40 times. And now clearing these variables, neighbors x and neighbors delta here. There is this is the another command for the MATLAB built-in function. Sorry, this is actually the file distance.m. So in inside distance.m, this function calculate this distance. So this is actually the used in this optimization algorithm. So here there is another call, there is another function, and some plus in the index. So right over here in this section the code is just updating the neighbors delta and neighbors x. Here is some notification about that. We should have to assign this in the start, but it's okay to go with that. Okay, so previously we have just clear these two variable from the workspace, and now in this program we are updating these based on the x and based on these numbers. So let's get out of this loop. And after that there is a separation based on the equation. There is a reference for that, and this is some calculation for the neighbors, and some the alignment and cohesion, and all these works together to improve the input, to improve the positions. And after updating the position, we have to send that data into. So at the end of this program for search agents, let me click here. So right here, food fitness, which is actually evaluated here. Okay, so after the end of this loop, we have evaluated the food fitness and the food position. So these are the 10 numbers, and this is the fitness we get using that. This is the loop which we have to run for multiple times, and this is the best score. Let me click on continue, and this loop will run for the maximum number of iterations, and then we have the best score, best numbers positions, and this is the convergence curve numbers. Let me click on step, main into DA. Let me click here. So after the completion of DA, we have three numbers: best score, best position, and convergence curve, which we get from this file. Let me remove this circle here, click on continue. Yeah, it's just is optimizing your problem, and now it's done. So we get the best score, best position, and the convergence curve for as we have the 500 iterations. So we have the 500 numbers, so we can draw a convergence curve based on that numbers. So here is some scaling for that, uh, for this plot. And then there is some labeling for that. Here is some labeling for that, and after that we have just the program has just displayed the best solution obtained by the DA and the best optimal value of the objective function. Let me click on continue. So this is the output. This is in form of this is the number of iterations, maximum iterations, and each iteration, when I move cursor there, you can see the fitness. This is for the iteration number 253, and the fitness value here is 10.07, which is then at the end of this program is actually 0.085 at the iteration number 495. So here you can see the numbers too here. The best solution obtained by DA is 1, 2, 3, 4. So these are the 10 numbers, and this is the fitness value for that. So if you want to apply this optimization algorithm to your case, so just make sure you have to work here in this part. In the F1 section, here is some inputs, lower and upper bounds for our case, and then this is the formula or the objective function. So you have to just make sure to change these two, and after that you have to run the program, start the debugger here, and each time you have to run the program step by step. If there will be any issue, there will be an issue with the program or instruction. Now it will be displayed here in the command section, and then you have to just tackle that, and you have to improve that, so your program will be working correctly. So hopefully you enjoyed this video, and please like the video, and thanks for watching.